Hi guys, in this video we will solve an interview question, and the question is remove duplicates from a sorted array. In this question we will be given a sorted array in which there are many duplicates present, and we have to find a new array, or I'll come to that later, and we have to return the length of the array which contains only the unique elements, that is non-repetitive elements. So, and we also have to update the given array in place without using any extra memory, such that all the duplicate elements are removed in such a way as in that after removing all the duplicate elements, duplicate values, the array starts from distinct values. Let me explain with this example. For example, we are given an array of in which there are 1 2 3 4 5 6 7 elements present. Now the new array will be I'll iterate through this array for explanation. First of all, we will go to the current element. As you can see, this is the first element. We will simply add the element to the array 1. Now we will check whether the next element is equal to the previous value or not. If the current value is equal to the previous value, we will get to the next element in that array, that is, we will get to the next index. Now as you can see, next element is 2, so we will shift 2 to the place of 1. Now we will go to the next index, which in this case is 3. As you can see, 3 is not equal to 2, then we will add 3 here. Okay, now we will get to the next index, which is this value. Now as you can see, the current 3 is equal to the previous 3, meaning that current value is equal to the previous value. Then we will skip this index and we will go to the next index. As you can see, this is a different element from the previous element. Then we will add 4 to the new array. We are not using any other array or any extra array. We are simply replacing the new elements with the previous duplicate elements in place. Now we will go to the next element, because our current index for that which is 5. Then we will go to 6, and as you can see, 5 is not equal to 4. We will add 5 here, and we don't have to take care of the remaining spaces here or what values are present here. We simply have to return the new array in such a way that all the first elements are distinct, and we don't have to return the array in the question, because in Java values are passed by reference, and this array is also passed by reference. So we don't need to return the array, and the array can be simply accessed from the calling function itself, or the array which was passed to the this method without using any extra copy. Now the length of the current array is 5. Now let me go through another example, which is in this example our given array is 1, 1 and 2. As you can see, the length is 3. When we will go on the first element, we'll simply add the element to the array, and then we will go to the next element, and we will check whether this element is equal to previous element or not. If the current element is equal to the previous element, we will go to the next index, and if the next element is not equal to the previous value, and in this case 2 is not equal to 1, we will simply exchange the place of 1 with 2, or we will simply overwrite 2 in place of 1, and we will simply return length of 2. And to calculate the length of the new array, we only have to update the value of counter by 1, that is we have to increment the counter by 1 whenever a distinct value is encountered. So let me code this example, let me code this solution, and it will become more clear to you. First of all, I will take 2 pointers, basically one extra pointer, int j, which and I will assign value 0 to j, and another counter variable which will be 1. Now we are taking count 1 because when we will add first element to the array, we know that the length will be 1 definitely, no matter even if all the elements are same in the array. Therefore the count will always be 1. Therefore we are starting with 1. Okay. And we will start iterating through the loop from index 1 because we are setting the j here, that is another index or pointer you can say, with 0. So we will check whether the current element, for example, let me take this case, j will point to this one and I will point to this one in case. Okay, then if current element is not equal to the previous element, and j here refers to the previous element, and I refers to the current element. Actually this will be nums and this will be also nums. If the two elements are different, we will simply increment the j pointer and we will replace the current value, or we will override the current value, which is j plus 1th index, with the current value we are iterating on in the array nums I, and we will also increment our counter. We can check here that if nums dot length equal to 0, return 0, but they usually don't provide null arrays. And return, here we will return a count. Let me run this code to check whether if there are any problems with this code. And let me also check with some random case. 2 3 3 3 3 5 6 7. Okay, so I will explain my case again. For example, we have an array, given array 1 1 2 3 4 4 5. Okay, and our initially j pointer is here and our I pointer is here. Now we will check whether the values at jth and ith index are equal or not. If they are equal, we'll simply increment the I pointer by 1, and we will check whether the current value is equal to the jth element or not. In this case, this simply means previous value, the value at which to which j is pointing, As you can see, these both these values are different, so we will increment j by 1. Now j will come here and we will replace it by 2, and now this 2 has been shifted, and now our pointer will refer to 3. As you can see, the value at jth index and the value at ith index are different. Then we will simply increment the pointer j by 1 and replace it with the value which is pointed by ith index, and 3 will come here. Okay, now we will again increment I by 1. Now as you can see, jth and ith value are equal, and we will simply go to the next value, that is we will increment our pointer by 1. Now as you can see, the value at jth index and the value at ith index are different, so we will again increment jth pointer by 1 and replace the value at jth index with the value at ith index, that is 4 here. Now again we will increment our ith pointer and check whether the value at jth index is equal to value at ith index or not. As you can see, the value at jth index and the value at ith index are equal, so we will again increment our pointer I by 1. Now as you can see, the value at ith index and the value at jth index are different. Then we will increment our j pointer by 1 and replace the value at jth index with the value our ith index is currently pointing. Now this will become 5, and now we don't care and at the last iteration we will increment ith index by 1. As you can see, now our loop will no more run because length is our ith index is greater than length, which is not true, and our execution of the loop will stop. Now I forgot to tell you that whenever the value of jth index and ith values at jth index and ith index are different, and we are replacing the value at ith index by first incrementing the jth index, then overwriting the value at jth index, we are also simultaneously incrementing the counter. That's how we are calculating the length along with identifying the distinct elements. Now as you can see, the length of this array will be equal to 5. As you can see, I have submitted this code. Oh no, I haven't. So let me check if there is anything wrong with this code. As you can see, our code is running successfully, and if you will submit your code again and again, you will see that there will be different usages in memory. Sometimes your memory will increase by some amount like 2 to 3 MB, or will decrease sometimes by 2 to 3 MB. I don't know the exact logic behind this, so this may be random, or there must be some kind of there must be something which has to do with code or load on the system at the current moment. So thank you for watching, and subscribe for more.